So today we will look over the problem 2018 AMC 10B problem 13, and it's a problem about modular arithmetic. So I strongly recommend you to watch the modular arithmetic series on my number theory playlist before you watch this video, as it requires some basic knowledge on how to use modular arithmetic to solve math problems. So the question says, how many of the first 2018 numbers in the sequence 101, 1001, 1001, 10001, all the way up to the 2018 number of this kind are divisible by 101? So our first impression of the problem is using divisibility. So it may be something related to using modular arithmetic, as this is about divisibility too. So firstly, we can try to express these kind of numbers in an easier form, and we can observe that we can express these in the form n equals 10 to the d plus 1. So it's a power, if we look closely, it's basically just a power of 10 plus 1. So a power of 10 plus 1, where d is a positive integer and d is larger than 1, because 11 is not included here. 10 plus 1 is not included here. So we want to find the number of numbers of this kind, which are multiples of 101. So we can so we're just looking for the number of numbers of this kind. Yeah. So we can look in modulo 101. I'll just move that to the left to have space. Modulo 101. And firstly, we can see that 10 squared plus 1, which is 101 itself, is congruent to 0, because 10 squared plus 1 obviously is a multiple of 101. And after that, we can put the 1 on this side to get 10 squared is congruent to negative 1 mod 101. And then what we're going to do is we're going to raise the power of both sides of this congruence to an integer k. So it will be 10 to the 2k equals negative 1 to the power of k modulo 101, where k is odd. And the reason why I put k as odd, well, we'll find out in a sec. So if k is odd, then this would be congruent to negative 1. This would be negative 1, because you multiply negative 1 an odd number of times. If k is even, then it will be equal to 1. So 10 to the 2k is congruent to negative 1 then, if k is odd. And then we get that 10 to the 2k plus 1 is congruent to 0 if we add 1 on both sides. Modulo 101. So we found that 10 to the 2k plus 1 is divisible by 101 if k is odd, if it's of this form. So we found that, and we can also see that this number is also of the form of this. So these numbers are included here. That's good. So we just want to find the number of numbers of this form, 10 to the d plus 1, where d is equal to 2k, where k is odd, where k is an odd integer. And this makes the problem a lot easier. So we just want, if d is of this form, then we can instantly find that that number is divisible by 101. So we can just find the number of possible values for d. So the number of possible values for 2 times an odd integer. And so we want to find such numbers 2k in the set 1, 2, 3, all the way up to 2018. Oh, sorry, it will be, so d, the set of all the possible values for d is basically 2, 3, 4, all the way up to 2019. So the first 2018 numbers of this form, it will be from 10 squared plus 1 plus 10 cubed plus 1, all the way up to 10 to the 2019 plus 1. And then, so we want to find the number of values of 2k, of the form 2k, where k is an odd number. And that's just going to be 2, which is 2 times 1, and 6, which is 2 times 3, 2 times 5, which is 10. And then we just keep going. Then we go all the way up to 2018, which is 2 times 1009, which is an odd number. and is of the form 2k. So these are the numbers of the form 2 times an odd integer in this set of numbers. So we just want to find the number of numbers in this set then, because that's the possible number of values for 2k. So how we find that is we can see that there's a constant difference of 4. So it will be 2018 minus 2 divided by 4 to see, because it's a constant interval of 4, and then it's going from 2 to 2018, and this just leads to 504. But then that's not the answer, because it's 2 to 2018 inclusive. So for example, if you count the number of numbers from 1 to 5, then you do 5 minus 1, and then you have to add 1 because you have to do it 5 and 1 inclusive. So you add 1 to 504 to get that there are 505 possible values for 2k, i.e. 505 possible values for d, so that 10 to the d plus 1 is a multiple of 101. And the number of possible values for d, if there's 505 possible values for d, so that it satisfies all these conditions, then there are 505 possibilities for numbers of the form 10 to the d plus 1, where d is larger than 1, so that d is larger than 1 and it's less than or equal to 2019, so that this number is divisible by 101. So basically 505 is just the answer. So we can see, so this problem is really interesting because we were slowly, through the use of modular arithmetic and reasoning, we were just making this problem much simpler, and we made it simple enough to make it into a problem where we're just counting the number of numbers in an arithmetic sequence. And maybe I'll do something on a video on arithmetic sequences, as that is an important topic too. So yeah, so hope this video allowed you to get a better understanding of modular arithmetic, because these properties, the properties used here, if you want to understand how this happened, then you need to have a good basic understanding of modular arithmetic. So yeah, hope you enjoyed this video, and see you in next videos.